Okay, welcome everyone. Thanks for coming. Here is the plan though. Welcome to the week one webinar. This is the first webinar that we're doing that is actually talking about statistics and learning statistics, whereas yesterday's webinar was the orientation webinar. But now we're going to be doing chapters 1 and 2. So let me tell you the plan for today. I'll start out as always. We'll look at any questions you have. I'll be happy to answer questions, and that could be about the class, could be about, whatever it might be. And as I want to remind you, if you put it in the chat box, then I don't mention your name. I just read it and answer the question. But you're also welcome to talk, and then it gets recorded. So I'll start there. And then what we're going to do is we're going to get into sampling techniques. One of the biggest challenges, actually, when you're collecting statistics and analyzing the stuff, is actually getting good data that is representative of the population without having horrible bias. And we'll talk about that. And like I said, it's a challenge, and I'll talk about some techniques that you can use that will help reduce the bias. Eliminating is usually impossible, but you can reduce the bias at least. Then after that, we're going to talk about, I know this is the name of the class, but statistics. So basically, statistics are the things that you get out of the data, the numbers that you get out of the data that will help you understand what's going on. And there's a big long list of them. We'll look at charts. Some of the charts you've probably seen in your life before, like the box plotter histogram, a histogram, bar chart, pie chart. But there'll be some others that you may not have seen, and we'll talk about those and how to create them too. Then we'll look at something called the Z-score, which is an important feature, and it's something that you get out of the data, and we'll talk about that. And then I'll talk about variables. There's different types of variables that can happen, and we'll get over to that. Today, there's a lot of vocabulary, especially in these chapters 1 and 2, whereas later on we have less vocabulary, but more like, kind of challenging ideas. Today, the ideas aren't challenging, but there's a lot of words, a lot of language. So hopefully you'll be okay with that. So that is the plan today. And again, I want to thank you for coming. And looks like we have a growing group, which is always good. And let me ask you again, I'll be happy to answer any questions you might have. And this is a great time to ask them, and I can answer them right away, or I can do my best to answer. If you ask me, how can we get peace on earth to happen forever? I could do my best, but don't trust me because I wish. But I can answer. I can try to answer your questions if you have them. Any questions? Okay, if there aren't any questions, just want to remind you, you can ask questions throughout the entire webinar. It's kind of the whole point. It isn't just some, you listen to me and that's it, because then I just make a video, which I've done already. This is supposed to be more of a conversation, and I'm going to have you actually do some of the stuff that we're going to be talking about in a way. So let me give you something that I read, and I don't remember where everyone is from, but I'm in Tahoe, and Lake Tahoe Community College is in Tahoe. So I read the Tahoe Daily Tribune, which is one of our big news. Um, used to be newspapers, but you know how it is nowadays. Now it's news websites. And one of the things that they had is they had a results of a poll that they did. And the survey question was, have you attended an event in the Tahoe Blue Event Center yet? So again, if you're not from Tahoe, you may not even know what that is. So what it is there's this big new, pretty big building where they have events, and it just got built, I think like 2 years ago or something like that. And it's somewhat a big deal. And they wanted to find out, are people actually going? Are people attending events there? And what they said, based on the poll, is 52 have not attend an event at the Tahoe Blue Event Center? By the way, I have. Okay, by the way, put in the chat box if you have or have not. Have you attended an event at the Tahoe Blue Event Center? If you've never been to Tahoe, the answer is definitely no. Okay, so we have both yeses and nos, which is good. I'm a yes, by the way. I have attended events, and the event was actually the college party. I don't know if you call that event, but I call it an event. So that's where I attended a few times actually, and both times college parties. So what they did is they posted the poll on their website, and anybody who's reading the website can go in and they can click on an answer to the poll. There was, I think, four or five or something different choices. One was I have not. There was one where I've attended an event that I don't know. They had different kind of events too to look at, and and what they got again is 52% have not. So, do you think that of the people in Tahoe, do you think 52% of all people in Tahoe have not attended an event at the Tahoe Blue Event Center? What do you think? Because that's what they've got. What's your thoughts? Put in the chat box. So, do you think that 52% have not attended an event at the Tahoe Blue Event Center? What do you think? Okay. All right. So the answer I see is no. And here's the issue. The issue is this is a survey. And the question is, for the people who answered the survey, clicked on it and answered the survey, do they represent the population of Tahoe? Or are they very different from regular people in Tahoe? The kind of person who's going to click on that survey thing. So, do you think they're probably pretty similar to just regular Tahoe people, or do you think they're special and different when it comes to attending events? And that's a hard one. And one of the problems is that we call this convenience sampling, which means whoever just wants to do it does it. Whatever's easiest to grab someone to do it, you're going to let them do it. Okay. And there's lots of problems with that. Okay. Maybe the person who tends to answer a question like that is a person who doesn't go to events. Who knows? But the problem is we don't know. That this could have a lot of bias involved in it. So now comes the hard question. If you were, say, in charge of the event center and you wanted to find out what percentage of Tahoe people have attended something at the event center, an event at the event center, and let's say you wanted to survey 266 people, but you wanted a representative survey that doesn't have bias. Any thoughts on how you might do it? Let's say you were paid $1,000 to do this. How might you go and do it if that was your job? Does that make sense? And I don't expect you to have like an answer that's perfect because it's hard. But what I want to do, and we're going to spend some time today talking about some possible ways of conducting a survey to reduce the bias. And that's a big deal because there are so many important things you want to find out about. But if you have bias, you really haven't learned by doing a survey. If you don't have bias, you've probably learned a lot. So here is another example where they actually used professionals and did their best they could to not have bias. And I like to bring in, new stuff. So this is from CBS News. And that is Americans are more hopeful about 2025 than they were for 2024. By the way, I'll let you answer the survey. Yes, if you're more hopeful about 2025 than you were about 2024, put a yes. If you're not, put a no. Put it in the chat box. Okay. I'm looking at the results from Lisa Chat, and I'm seeing no's. But I want to let you know this is a complete biased sample. It's just you all, and you're definitely not just some random people in America. Does that make sense? So that would be a terrible way of doing a survey. Nothing wrong with you all, by the way. It would just not be the best way of doing a survey. Okay, so what they did, and now I've kind of read this and I copied and pasted this out of the article, and that is the CBS News YouGov survey was conducted with a nationally representative sample of 2,244 U.S. adults interviewed between December 18th and 20th in 2024. So I want to focus on right here, this nationally representative. And that's what you want, if you can, to not get biased. So how might they have done it? They did not actually, I read the article and it didn't show all the details of how they did it. But if they really truly did a nationally representative, let me explain how they could have done it. And what they probably did was use what's called stratified sampling, which is the most common method of sampling when you want to reduce bias. Doesn't make the bias zero, but it makes it less. So what you do is identify what you want to make sure that you have a representation of. So some of that could be age. So if you only asked young people, they might think differently than if you only asked old people. So you don't want to just ask young people or just ask old people. You want to make sure that you have a nationally representative group of people who answer your survey question based on age. And the way you would do that is you would look up the percentage of each age group, and you can, I don't know, you can do like, the boomers and the Gen X and the Gen Y and the Gen Z, and you can do maybe each of the gens, say what percentage of the population of America is of each of those groups, those age groups. And then what you do is you make sure that the proportion of people that you survey in each of the age groups is equal to the proportion of the age groups in America. And that makes it nationally representative. Any questions on that? And if you don't remember the math, the way you find proportion, the way you find the number of people you need to survey actually is you take the sample size you want. So if we wanted a sample size of 2,244 US adults, and let's suppose, and I'm making this up because I don't know, let's suppose that 20% of them were Gen Zs, then you would multiply 2,244 times 0.2, and that would be the number of Gen Z people you would survey. Any questions on that idea? Okay, so age would be one of the strata that you might want to do. Another might be gender. And then you're going to say, well, of Americans, what percent of Americans are male? What percentage of Americans are female? And what percentage of Americans are other? And then you do the same thing. You research, you find out the percents, you multiply the percent by the sample size that you want, and that is going to be your quota for each of those genders. Any questions on that idea? And then if you do that, then there is no bias based on gender because you made sure that you have the right proportions. Others could be income because That might have something to do with whether they're hopeful about 2025. Depends on how much money they make. Okay, there's what other strata might there be besides age, gender, and income? There's a whole lot, by the way. What are the things you might want to look at and ensure to prevent bias based on it? Put in the chat box the idea of what other strata besides gender, besides age, gender, and income. Hopefully, you're all typing. So, what other strata would there be? There's a lot of them. There's a lot of good choices, by the way. And if there's ever something you think that could cause bias, if you only picked a certain group, then you want to, use that as one of your strata. So I don't see you typing in. I don't see anything new. Hoping to see some. Any ideas? Okay, eye color. That could be. Because I don't know, maybe people with blue eyes are, more pessimistic about next year or something. I have no idea. But that's what you thought, then you would use eye color. That could be. Preferences for something, I guess. That could be. Um, but there are a lot. Race would definitely be one. And others that are common besides income and gender and age and race. Um, then there's location. Where do you live? What state? Okay, I live in California, for example. Californians might be different than, say, people who live in Arizona. So you would want to make sure that you have the right proportion for each of the states. That's not the same thing as the same number of people in each state. You'd want a lot more Californians, for example, than people in Nevada. How come? If you were conducting a survey and you wanted to do stratified sampling, why would you want to make sure that there's a lot more people in California that you survey? Any thoughts? Hopefully you're typing. So what would the problem be if you said, all right, we'll just get, 50 people in California, 50 people in Nevada, 50 people in Arizona, 50 people in New Mexico, just go through and 50 of each, and we'll call that stratified. That would not be stratified. Okay. So the reason I don't see anyone coming up with the true reason. The reason, we're not doing actually we're talking about more hopeful about 2025 now. We're looking at this one now, a new one. So the reason why you'd want more people in California is because the population of California is like close to 40 million people, whereas the population of Nevada is like a couple million, and that's it. So you want to make sure it's proportionate, not equal. Do you see how that works? And that's how it works for stratified sampling. Any questions on that? Okay, so just some note that because these kind of come up a lot is that there are a couple kinds of variables that we want to really understand that come up a lot. One is what's called qualitative. Qualitative means the answer to the survey question is a word, okay, and not a number. So that would be something like, what is your favorite color? Maybe you could put in the chat box. What is your favorite color? Do it quickly. You should be able to say this fast. What's your favorite color? Okay. Mine is green. I see blue. I see pink. Notice you didn't put 73 because this is a qualitative survey question. Quantitative means you have number answers. And that would be something like maybe how many units are you taking right now in college? Maybe you can tell me how many units are you taking? Okay, notice that you're answering numbers like 12 and 19. Okay, I know all of you at least are taking 5 because this class is 5 units, but you're giving me numbers. So how many units you're taking is a quantitative survey question, whereas what's your favorite color is a qualitative survey question. Is that clear? So I got a lot of language today. Okay. Just a note, sample size, I guess their sample size, I think I typed it from an old one, 2244 for this last example. We're always going to use the letter N for sample size, and N stands for number, number surveyed. So if you see the letter N, lowercase n, it's always lowercase n, is the sample size. Capital N is usually the population size. Sometimes you don't even know what that is, but the sample size you should know. Okay, any questions on that? I think I'm going to wait on the next one. So I want to go through sampling techniques. Okay, we've talked about a couple of them already, but let me talk about the rest. One is random sampling. Let me ask you, if you wanted to conduct a random sample of Americans, say based on, you want to find out if they are more confident about 2025 than 2024, could you do that? Could you get a random sample? Could you randomly pick people? Any thoughts? It's a yes or no. Could you do it? Okay, I'm seeing you say yes. All right. So I'm not gonna tease you or anything, but I want to let you know, good luck. It's not gonna happen. You can't do it. There is no way of getting a random sample of all American people because you can't do it. The only really way to get a random sample is to put every single person, get them, say, in a computer, let the computer randomly pick the people, and then go and survey and make sure that everyone you picked answers your question. And I will let you know that is not even possible when it comes to the population being all Americans. You can't get all Americans in a computer and pick because you can't get a list of every American and know where they are and know how to find them. So when you have things like a population of all Americans and you want a random sample, you can't. Does that make sense? Okay, you just can't do it. Okay. There are some situations where you can do a random sample, but not the all American example. Okay. If you wanted to look at, say, counties in California, that you can pick a random sample of counties in California because you can list all of the counties in California. You can go online and find them pretty easily. Put those counties in a computer, have the computer randomly select, say, 5 counties if that's what you wanted, and that would work because you can actually list them all. If you can't list them all, you can't do it. And counties don't decide to say yes or no. It's a county. Do you see? People can say yes or no. They can say, I don't want to do this survey. Forget you. And then you don't have a random sample. Do you see that? So random samples are most of the time impossible, especially when you're talking about a large population of people as the population. Is that clear now? Those of you thought it was yes, you could do a random sample. Do you agree you can't of people in America? Okay, you can do a stratified sample because you can find out the percentage in each kind of group, and then you make sure you establish your quotas. But you can't do a random sample. Okay, so there is simple random sample, and that's even weirder. And that means that you have to order the whole population, and you have to pick the numbers and do it that way. And that turns out to be even harder. I'm not going to get into too many details on that. But simple random sampling means that every group of n individuals has the same probability of getting selected as any other group of n individuals, which is almost impossible to do. Okay, stratified sampling, that's what I just talked about. And by the way, here's the steps. Step one, decide on the strata. And that could be, for example, age. Step two, research the percent of each type. Step three, multiply the percents by the sample size to establish quotas. And step four, conduct the survey, ensuring the given quotas. I will let you know that you're actually going to have a couple choices for project one. You're going to have to conduct a survey, and one of the options is to use stratified sampling. So I'll let you know the other in a minute too. Any questions on stratified sampling since we just talked about it? Okay, then comes cluster sampling. Cluster sampling, you divide the population into clusters that represent the population, and then sample every item in each cluster. So let me give you a common example. Let's suppose you wanted to survey, let's say, maybe a couple of hundred students at our college. Then any ideas on what the typical, kind of the easiest clusters to use would be? And clusters or groups of students in this case. What do you think that kind of the obvious set of clusters there could be if it was students at our college? Was the population? Ideas? Don't hear it. When I say you, it'll be obvious, hopefully. Okay, the typical, kind of the easiest cluster, the most typical for college students would be classes. If you want to survey a couple hundred students, you might pick, our college has small classes, by the way. So you might pick 18 classes or so, and then make sure those classes are representative of the college. So don't pick all math classes, for example, or all of something. You would pick maybe a couple math classes, a PE class, maybe some English classes. So you'd pick a few classes that are representative of the college, and then you go in and you would survey every student in each of those classes. Okay, which you could do. Any questions on that idea? Okay, let me talk about the next one. That is systematic sampling. And in general, that is survey every nth item in the population. Okay, this is especially done in manufacturing. So let me give you an example. It was a former student of mine that came up, got a business, and he actually made towels for hotels. That was his business. That was his company. He manufactured them. And he wanted to conduct a study to show his towels were better than the made in China towels. And actually, he emailed me asking for help on conducting a study without bias. And for what he was doing, systematic sampling made sense. Because what he had to do is he had to look to see how long it would take before the towel got destroyed. And he wanted to show that it took longer for his towels to get destroyed than China. And he wanted to look at his towels. So what I had him do is I had him take every 200 towel out of the assembly line and use that. And that would be a systematic sampling because every nth item in the population. If the population's not ordered nicely, then you can't do systematic sampling. Does that make sense? Okay, convenience sampling. We already talked about that. You just collect data on whatever's the easiest. Okay, let me give you another example on why convenience sampling doesn't work. Let's suppose that I wanted to find out the average height of students. Okay, students in California. Sound good? College students. So I don't know. What would be convenient would be just get the heights of the very first class I ever taught and just get their heights. Sound good? Isn't that convenient? You want to hear why it would be really biased? I will tell you the average height of that class was 6'11", approximately. Okay, I know you think I'm like joking, but I'm not actually. Anyone know why? Any guess? I don't see y'all jumping in. Okay, it turned out the very first class I taught, and I didn't even know I was going to do this until they showed up in class, was the UCLA basketball team. And yeah, it would have been convenient to just measure them, but that would be total bias. Do you see that? To just go to a basketball team and look at them because that's easy because they were my first students. So that would be bias. It would be a terrible sample in terms of thinking that would be representative of the population of students. Any questions on that? Okay, then there's another type that's used a lot, especially in medicine, actually. Let me ask you, because I know I usually get a lot of people that are interested in joining the medical field. Are you thinking about joining the medical field in your job or career? Yes or no? Oh, look at that. Okay, I usually get a group. Usually, like almost half my students are, but I'm getting a bunch of no's. Okay, but so sorry if you're not interested in this, but um, there's something called the randomized control study. Okay, and let me give you, and I'm going to talk about this later too in a different week. Let me give you, I consider it one of I would say the most important statistical analysis that's been done in the last decade. Any guess on what that might have been? Any ideas? Not seeing y'all jump in. Okay, and you may not agree with me, but this is what I think was the most important in the last 10 years. That is deciding whether the COVID vaccine worked. Do you agree that was kind of an important statistical study? And being a statistician, I read everything about it before I got my vaccination. Okay, and what they did is they used a randomized control study, and what they did is they actually got 40,000 people who volunteered, and they put their names in a computer, and then they randomly selected. It turned out it wasn't half of them, but a large group of them to be treatment group. And the other group that was the other side was the control group. So the treatment group got the vaccination. The control group got a shot that had nothing in it, thought they were vaccinated. And then they looked to see what percentage of the treatment group and what percentage of the control group ended up getting COVID in the next, I don't remember how many months, but some months. Does that make sense? And because they did it using a randomized system using a computer, there was no bias. And that's how that was done. And it was, I believe, a double blind study, which means even the person giving that was giving the shot to the person didn't even know whether that shot had the vaccine or it was basically empty. So that's a really good study, and it's used a lot in medicine. And honestly, I was part of one when I was in college. Um, I turned out to be the control group, and I didn't get better. And then they apologized a week later, and they gave me real medicine. But they gave me money for being part of the study. So I've actually been on the other side of it. And it wasn't the best experience for me, but that's okay. I didn't die. Okay. Any questions on randomized control studies? All right. So what I want you to do, and it's going to be one person, first person who does it. I want you to put in a chat box a quantitative information or survey question that you're interested about the group here. And it's not a huge group, but you're all going to have to answer it when you're done. So in other words, quantitative means the survey question should have a number answer and something you might be interested in finding out about each other. And let's see if one of you can put in the survey question, something you might be interested in about you all. And there's unlimited number of choices, so please put one in. So what's the survey question that is quantitative? So for example, the one I asked you a while back was how many units are you taking? Don't ask that one because we already did that one. So ask another quantitative survey question. Okay. How many students of color? The question is you're asking one individual. Does that make sense? So the survey question with the first how many students of color would be, are you a student of color? And that'd be a yes or no. That'd be qualitative. Does that make sense? Okay. How many years until graduation? I'm going to change it a little bit just so that we can have more interesting numbers. How many months? How many months do you expect until you graduate? Sound good? Okay. And again, what is the number of Apple users in the class? That would be a yes/no question because the survey question would be, are you an Apple user? Do you see? So what I want you to do is put in the chat box, I want you to answer. How many months do you expect there to be before you graduate? And just put a number in. For some reason, if you don't want to tell everyone, just put a number in and don't worry, it doesn't have to be real. But do something reasonable. Don't say 3 million months because that can't happen. Okay, and everyone has to answer, by the way. Watching the numbers. Okay. All right, so we'll take these five, and we have 12, 8, 12, 12, and 4. Got it? All right, so first thing, when it's quantitative, you can get numbers as the answer. So how many months would be, that would be quantitative. Do you see that? So that would be quantitative. Whereas, are you an athlete is not quantitative. All right, so now what I'm going to do is now let's look at this data and let's get statistics. So I'm going to copy this. I'm going to go to the calculator. And by the way, this calculator is really important. This class, when I first taught this class, we did not have a statistics calculator. They didn't even exist. In terms of good calculators, it was a brutal class. But we're not there anymore. So what we're going to do is we're going to go to one variable statistics calculator. We could do random number generator for something else, but we're at the beginning of the class, so we're here towards the beginning. One variable statistics. It says type in the values from the data set separated by commas, which I did on the other, and I hit copy, and now I'll paste. And that's our data. Any questions on that? All right, I'm going to consider you as a sample. It's convenience sampling, but it's still a sample of, let's say, all online statistics students at community colleges. Sound good? So that means I'm going to click sample standard deviation and hit calculate. Was that hard or was that easy? Yeah, so I try to make the calculator. I programmed this. I made this calculator. I try to make it easy. But if you ever have any suggestions to make it easier, let me know. But in this one, that's all you had to do. So now what it's going to give you is it's going to give you statistics. And there are a lot of statistics. Some you all already know. Some will be new for y'all, and you haven't necessarily seen them before. So I'm just going to kind of go through basically in order of what we've got. So first thing, this word mean, when you talk to say, when you were say 12 or 13 years old, use a different word for that. Do you know what word you used? Do you know what the word mean also what word it also is used? What you'll see. But in our class, we're going to use word mean because that's standard for advanced stuff. You don't know what the other word is that everyone understands? You can pop in the chat box. Any ideas? Okay, if you don't know, let me tell you. Average. You've all heard that, right? Average. So in statistics, for some reason, and I have no idea why, but in a stats class and every statistics book I've ever seen, they use the word mean. So we're going to use the word mean. And not because I'm being mean to you, by the way. It's just the word you use for the average. It means add them up and divide by the total. And that was 9.6. That means the average number of months until people expect to graduate is 9.6 months. I hope you all know what the word minimum means. 4. So that was the smallest number, least number of months that someone expects to graduate in. Okay. There's Q1. That's a newbie. Okay, that's something that most of you probably don't know what it means. Q is a letter that stands for quartile. Quartile. And what that is it is a number such that approximately 25% is at or below that number. Okay, it turns out the math formula is really complicated and people don't even agree. I want you to understand the idea. I don't care about using the formulas. Okay, sound good? The median, you probably have heard the median. Maybe you can put in the chat box what the median, what that tells you. That's a word you probably have seen before. I think you get it in middle school, maybe high school. Any idea what the median stands for or what it represents? Well, see y'all jumping in. That's basically the middle number. So if you list the numbers from lowest to highest, and if it turns out if there's an odd number of numbers, it's the middle number. If there's an even number of numbers and you list from lowest to highest, there's actually 2 in the middle, and it's the average of the 2. But it's kind of the middle. Does that make sense? Then there's Q3. Q3, kind of like Q1. Q1 means 25% is kind of at or below. Q3 means 75% at or below. Okay. Median, by the way, is 50%. Then there's maximum is 12. Hopefully you all know what that means. That's the highest number of months before. So the highest number of months someone expects to graduate in is 12 months. Okay, this is a biggie, standard deviation. Okay, this is definitely, I would say, the most important of the ones that you may not totally understand. Okay, so the standard deviation gives you an idea of how spread out the numbers are. If the numbers are all close to the same number, they're all close to the mean, then the standard deviation is going to be very small. If the numbers are really spread out, then the standard deviation will be large. Okay, so the standard deviation is an idea of how spread out everything is. And we'll look at some examples in a little bit. The variance turns out to be the square of the standard deviation. We're not going to do much with that one. So for the project, you don't even need to talk about the variance because it doesn't have very good meaning unless you're a mathematician. I'll let you know that. Okay. IQR stands for interquartile range. And what that is if you take Q3, which was 12, and subtract Q1, it's a 6, it's going to be 12 minus 6, and that's what that 6 is. And that is what the range is from Q1 to Q3. And the most important part of that is that's the middle 50% range. How spread out the middle 50% of the answers to the survey question was. Okay. And that's the IQR. Sometimes you'll also say the IQR goes from 6 to 12. That's another way of saying it. It's really important in, say, business, because in business, you want you want to find out who the typical person that comes to your business is. And the middle 50%, that's your typical. Do you see how that works? Sample size, hopefully you know what that means. 5. 5 people answered the survey question. Any questions on that idea? On any of these? Okay, these are all called statistics. Statistics are numbers that come from the data. What I'm not going to do, but you're welcome to, read the book and see all the details, is I'm not going to go through the formulas for all of these. But there are mathematical equations for these, and you don't need to, well, you're never going to be using them. What you are going to be doing is using the calculator and let it do all the math for you. Okay, sorry if you love math so much that you want to do all the math by yourself. You can, but it's a lot of work. Let the calculator do it. And this is one of those I'm going to tell you, trust me. I coded this calculator and it works. It's going to give you what you want. I will tell you there's a few ways of getting Q1 and Q3, and I coded it in the way the system was doing things, and that works. It turns out there's different way. I'm just not going to get into the details, but I just want to give you that warning on that. But it works. Any questions at all on any of these statistics? Okay, we're going to look at some more. Okay, we still have more time. Okay, and this is important, by the way. Remember, what's the name of this class? What's the name of this course? What did you register for? Yeah, elementary statistics. Okay, so if you don't understand statistics at the end of this class, you're not passing this class, because this class is statistics. So all these are really, really important. Okay. So let me move on. And so these are all the things I want to talk about that I already talked about. Notice, by the way, standard deviation, boldface, really large font. Any guess on why? Okay, I don't see you guessing. Here's the reason. Because you must fully understand it. It is absolutely essential in this class. We're going to spend a lot of time on the standard deviation, and then something called the standard error, which is something related to the standard deviation. So that's a biggie. If you don't understand that, please get help. Log into my office hours, go and get help from a tutor. The standard deviation is really, really important. Okay, so I listed a bunch of these. There's another one that's important that's called the z-score. Okay, and by the way, there's all these other ones that we already talked about. And the z-score has a formula, and that is x minus mu over sigma. So let me read these out to you, because this is really important in terms of the letters we use, because we are always going to use the same letters for this stuff. Z is the z-score. That's an obvious letter for z-score. X is a number that you're interested in. This is a Greek letter right here. Okay? And I will tell you, I have a cat. She loves this letter. You know why? Do you know how I know she loves it? Because every time she looks at me, she says, meow, meow, meow. That's how you read this letter. It's mew. Okay? Just think about the cat. And here's, you can see the little tail at the bottom of the left, on the left. Think of that as the tail of my cat. That'll help you remember. Okay, so that's mu, and mu is the mean, okay, which is also called the average. Okay, this guy at the bottom, that is a standard deviation. And the way you read that is sigma. Okay, these are Greek letters. Don't get mad at me. This is what everybody in the world uses. So sigma is the standard deviation. So the z-score is a number minus the mean divided by the standard deviation. And what it does is it kind of tells you how unusual something is. Okay, if something's very unusual, it's going to have a very high z-score or a very low z-score, meaning like -3. Okay, so let's look at a bunch of things, and I'm going to go through some of this stuff. So here's an example. My goal is to have most of the students in our class pass. Okay, hopefully you're okay with me wanting you to pass. I really want you to pass. That's my goal. Okay, and to pass, you have to have 70% or higher. So if you paid attention in the yesterday's webinar, then 70% was C or was the lowest C you could get, and anything higher than that is a pass. Okay, let's suppose I told you that the average score in my last class, last quarter, was 74%. Have I reached my goal? Am I satisfied? What do you think? If the average score, which is mu, the mean score, is 74%, am I satisfied? Have most of the people pass the class? You have to have over 70% or higher to pass. If the average score was 74%, am I satisfied? What's your thought? Okay, I don't see you all jumping in. Okay, so the answer, this is a trick question. The answer is you have no idea whether I'm satisfied or not. Because without knowing the standard deviation, you don't know. The average score is 74%. That's a passing grade, right? If everybody got a 74%, then the average score would be 74%, and everyone passed. I'd be celebrating because everyone passed the class. Do you see that? But what if one student got 100% and just about everyone else got 69%? Then the average score would probably still be about 74%. And almost everyone did not pass the class. Does that make sense? So if you only know the average or the mean, you don't have that much information. You don't have enough information to really focus and understand. So now let's suppose I had the average score was 74%. And let's suppose I also knew the standard deviation was 0.02%. Am I satisfied? What's your thought? Put in the chat box, yes or no. Am I satisfied? Have I met my goal? What do you think? Okay. Yes or no? Have I met my goal? If the average score is 74%, standard deviation is 0.02%. Have I met my goal? Yes or no? I don't see y'all jumping in. I'm hoping you answer. It's only 2 or 3 letters to type. Okay. Okay. All right. So here's the deal. The answer is yes, because the standard deviation is 0.02%. That's a tiny number. If you take 74% and subtract 0.02%, you actually get 73.98%. That's still passing. If you go 2 standard deviations below, that'd be 0.04%. That's still passing. Even 10 standard deviations below would be still passing. If the standard deviation was 0.02%, then everyone passed. Do you see that? Because the average score is like so close to 74% that everyone passed. Everyone got a C. No B's, no A's, but everyone passed. Any questions on that? On how you kind of see that and understand it? Because we have a tiny standard deviation, means they're all just right close to the mean, and that's passing. Any questions on this idea? Okay, so let me give you what's called the rule of thumb. Have you heard of a bell-shaped curve? You heard of that word? Something's bell-shaped, a bell-shaped curve for distribution has that there and there and there. In fact, I can go and just put into Google normal. And I'm going to put normal distribution. We're going to use the word normal, not bell-shaped. And let's go to images. And there's the normal distribution shape. You see that? And that's the shape of a normal distribution. It turns out the normal distribution is by far the most important distribution of this entire class. So we want to really understand that. So just to note, something called the empirical rule says that if you follow a normal distribution, then there's a 68% chance of being within 1 standard deviation of the mean. There's a 95% chance of being within 2 standard deviations of the mean. Okay. For our class, this is important, by the way, because AI will not always agree with me. So don't use AI. For our class, if I ask you if something's an outlier, you see how many standard deviations from the mean it is, which, by the way, is saying find the z-score. If it is more than 2 standard deviations from the mean, we call it an outlier. Got it? Take that, write that down on paper right now so you don't forget. Okay, I'm going to say that a lot during these webinars. That's important because that's going to be our class's definition. There's more than one definition of outlier. This is our class. If you don't use this one, you lose points. Okay, that's because this is the most common definition, but there's others also. This is the one we're going to use. Okay. For this, also called empirical rule, there's a 99.7% chance of being within 3 standard deviations of the mean. So 95% chance, that's a pretty high percent chance. So within 2 standard deviations, very common. Within 3, it is very rare, extremely rare to be more than 3 standard deviations. And if it's more than 3 standard deviations from the mean, we're going to call it an extreme outlier. So get these words, take notes on this one. These are words you should be writing on paper. Got it? Any questions on what this is? Okay. The z-score measures how many standard deviations away from the mean a value is. And let me just give you some examples. Actually, those will come a little later, I guess. Well, maybe I'll skip this and go to the z-score. and then go back up. All right, so I like this example. And sorry if none of you are going to go into medical, but it's kind of a fun one. Suppose that you are in the hospital and you're taking care of an infant. Okay, the infant was just born. Okay, so by the way, my brother actually, that was his job for a long time. He was he delivered babies. That was his job. He's a doctor, by the way, and he delivers babies. So let's suppose that you're in the hospital, you're working delivering babies, and a baby was just born, and the Z score was for the weight of the baby was negative 3.7. What will happen to the child? Any thoughts? Any thoughts? What's going to happen to that child if the weight of that baby is negative 3.7? Put in the chat box your ideas. Okay. Yeah, so undergo some treatment. Okay, underweight. Okay, I'm gonna actually give scarier words. Your ideas are right, but let me be scarier. That baby is gonna go directly to the ICU and probably won't live because this baby is an extreme outlier in low weight because 3.7 is pretty much farther away from zero than 3. You see? So this is like an unheard of low weight, and babies don't live when they're that small. Okay, that baby is probably going to die. Okay, it's sad. I don't want to be depressing. There's a chance that maybe you'll be able to do something and help that baby, but that baby is going into the ICU immediately. Does that make sense? It's not just a little underweight. It is extremely light. Do you see that? Okay. All right. The next infant that you're taking care of just got born, and it had a Z-score of 3.1. Now, what do you think the hospital is going to do? What's going to happen? Any ideas? Put in the chat box. Yes, doesn't mean it's underweight. It's extremely underweight when it was negative 3.7, by the way. Okay. And again, if you don't understand medical care that well, you may not be an expert on babies, but I will tell you, I wouldn't, I don't expect you to do that to know for sure, but it's not like you lose points during the webinar. Okay, so now we also have an extreme outlier. It is extremely overweight. Extremely overweight babies actually, they don't die. But the mother went through really hard labor. Definitely had a C-section. Okay? Because that baby was so big it had to get pulled out. And that baby, that woman, so the mother of the baby needed a C-section to get that baby out because it wouldn't fit to get out of the womb. Does that make sense? Because it's extremely overweight. Any questions on that? Okay, now let's go to the third infant. There's a third infant that was born with a Z-score of negative 0.19. Now what can you say about the third infant? Or the mother? Okay. So for the third infant, now it's negative 0.19. That is actually very close to 0. Because remember, 2 and negative 2, those are the outliers. This isn't even any close to that. This is really close to 0. So what you would say with this baby is, this is a normal baby that's really close to average. Do you see that? Yeah, it's very, very tiny below average. You wouldn't even say below average. You would say this is an average baby. Do you see how that works? Okay. I will let you know in the project, you're going to have to do this kind of thing. You're going to have to analyze z-scores and you're going to have to write about it. Okay. So, and it's not going to be about baby weights. It's going to be whatever you're interested in doing, but you're going to have to do it. Okay. I'll talk a lot more about the project in another week. Any questions at all on this example? On this example of z-score? Okay. All right. Here's there's lots of examples where z-scores are important. Another is I took the SAT when I was in college. Okay. And I got a 1,592 score on the SAT. What do you know about how I did on the SAT? I know people don't take SATs too much anymore, but in my day, you had to. It was a requirement. Any idea? An SAT, if you don't know, it's a test you take that kind of tells you how ready you are for college, is the idea. So what do you know if I told you I got a 1,592 on the SAT? Any ideas? Okay, the answer is you don't really know anything probably because I have no idea how old you are, but my guess is that you're all probably under 40 and you don't even like have any idea what SAT scores were in those days, what was a good score or a bad score, right? So if I gave you that information of my score, which sounds like the perfect good information to give you, it's useless. But what if I told you that my Z score on the SAT was 2.6? Okay, I still only gave you one number. Now can you say something? Did I do well or not well on the SAT? Or did I do average? If my Z score was 2.6. Yeah, I did very well because I'm an outlier. That means I did really well. Okay. And by the way, they actually, I'm not going to go into the details. They had a math portion and they had an English portion. Um, and any guess on which I did better in? Yeah, math. My Z score in English was really close to zero. It was basically a zero, and which means I was just an average person. And then my Z score in math was over four. And that is like, uh, I have my one talent. That's all that is. But English, I know how to read and stuff, but I'm not special at all. Okay, so but if you know the Z-score, you really understand how unusual the person is, how low or how high. If you know the mean, you may not have any idea. So Z-score gives some really good information. Any questions on that? Okay, so the next thing I want to talk about are charts. And the charts, the main charts that we're going to look at, and I want to look at them instead of just kind of describing words. These are words, but let's take a look. And I'm going to go to the other calculator, the spreadsheet calculator. And in the spreadsheet calculator, I actually coded it to show, to have some charts to show. So this is an example of some data. Okay. I think it was the data I put in, last time. And you'll notice there's a histogram. So a histogram is a special kind of box plot. Sorry, not box plot, a special kind of bar chart. So what it does is it has bars. And we'll see this 4 here and this 5.1. And it is a rectangle here and it goes up to 4. What that means is that 4 of the data values are between 4 and 5.1. For the next one, 5 of the data values are between 5.1 and 6.2. Do you see how to read this histogram? Okay, this is a histogram, and so a couple things for histograms. A histogram, the x-axis has to have numbers. Okay, if it's a bar chart where the bottom has words instead of numbers, different types of things, then that's not a histogram. That's just a general bar chart. Histogram's a bar chart, but it's a special kind of bar chart. Any questions on that? Also, the interval have to be equal width. So the width of every bar has to be the same throughout. Any questions on this idea? Okay, this example right here that we're looking at, we're going to call it unimodal. Do you know what uni in English means? You've seen it in other words as a prefix. Uni? Yeah, it's one. Like unicycle means there's one wheel. Unimodal means there's one mode. Mode is the high point, the most frequent. Okay, so this has one bar that's higher than any of the others. Okay, by the way, if we had a different histogram and I told you it was bimodal, what would that tell you? Yeah, that would mean there's two bars that are the highest and they're equal to each other. Okay, so just some language. We also say with this histogram, notice that we have the high stuff on the left, and then from there it kind of goes down on the right. When we have that shape, we call it skewed right. So skew is where that kind of far away stuff is. So that's on the right. Okay, if it were the mirror reflection of this, we call it skewed left, by the way. That would be if the kind of that skew was on the left-hand side, or the tail was on the left. If the tail's on both left and right, then it's not skewed left or skewed right. Then it's pretty symmetric typically. Any questions on that? Okay, so this is a histogram. Let me just show you some more. If I go to stats and I go to box plot, then that's going to give us another picture. And I want to give you a warning. When you use this, if you use this spreadsheet calculator, it might give you some big warnings that this could like destroy your computer. I coded this. I would never do that to you. So click yes, I'm okay. Let it happen. Just let you know, because the computer gives you warnings that it might destroy. It might, have some evil virus, and it doesn't. There's no virus on this. I would never do that to you. Okay, so this is what's called the box plot. Often they'll call it box and whiskers plot. Kind of two names for it. Sometimes box, and whiskers, because you can kind of see a box here, and then you can see here at the top and the bottom. They call these whiskers. And they say this describes what's called the 5-point summary. So this 4 right here, this bottom, which is 4, that is the minimum. This 9 here at the top, that's the maximum. Got it? This middle line here, which is 6.5, okay, then that was the median. This bottom of the box, which is 6 here, that is the first quartile, which I called Q1. And the top of the box is the third quartile, which is Q3. So by looking at this, you can really understand a lot about what's going on. Because you can see the median, you can see the interquartile range, you can see the max and the min. You can't see everything. You can't see a standard deviation, for example. You can't see any individual data values, but you can see a bunch of stuff. And let me tell you one big issue with the box plot. If you were having to give a presentation and it was with a bunch of uneducated people and you use this box plot, they would have no idea how to read this. So you really only use box plots when you're presenting to people who you can assume know statistics. Okay. Or at least remember their statistics. Okay. And I'm not sure, I have no idea how old you are, but I know that supposedly the new standards in high school, you're supposed to learn what a box plot is. And that's been the last 10 years or so. Before that, that wasn't even part of school. So you might have seen it before. Any questions on the box plot? Okay. Now let me give you another one. If I go to stat and I go to stem and leaf, this gives you another visual presentation. Okay. This one's not very interesting. Let me do one. Let me change the numbers a bit to make it interesting so it's actually worth it. Let me erase these and let's do a different one. Let's suppose I asked how old you were. And let's suppose the first person was 18 years old, the next was 21, the next was 24, the next was 35, the next was 16, the next was 22, then we had a 19-year-old, and then another 18-year-old, and then a 20-year-old, and another 20-year-old, and then a 29-year-old, and a 24-year-old. How about a 41-year-old? Another 22-year-old. Okay, so now if I go to the stem and leaf, it'll be a little more interesting. So let's do a more interesting one. So you want to have, by the way, for your project, you want to have, make sure you have 2-digit numbers if you can, because then you could do stem and leaf. It'll be interesting. So if I go to stats, stem and leaf, I need to do one more thing, sorry, because this was set because I was showing someone. That needs to be a 1. There we go. Then this gives you really it's kind of a special kind of histogram, but it does more than just a histogram because you'll notice there's numbers here. And you'll see like this very bottom one. See this 1 here? Notice it's under the 4, and that tells you had someone who was 41 years old. See, we have, for example, we have an 8 and an 8. That means there were 2 people that were 18 years old. So from the stem and leaf diagram, you can see exactly what the data values were. Whereas with the other plots, you weren't able to get the exact data values. You only got ranges. But with the stem and leaf, you get the numbers, you get the values. Any ideas on why the stem and leaf would be not a good idea to present with? Kind of situations? Kind of 2 situations where it's not a good idea to present. Any thoughts? Okay, it can be confusing because of the way the numbers are split. Yeah, so people who don't understand, just like with the box plot, people who who haven't taken statistics will have no idea how to look at this. Do you see that? So this doesn't work for uneducated people. That's why it's confusing. If you've taken a stats class and you got a good grade because you really understood it, then you should be able to see this, no problem. Does that make sense? But if you have not taken a stat class, you have no idea how to see this. The other issue, and it's not an issue for this example, but let's say we had a million data values. This doesn't work because you can't fit a million numbers on one screen. Do you see that? So this only works with kind of not too giant sized sample sizes. Any questions on that? Okay. But what's great about it is it gives you back the data. You can look at this and see exactly what the data values were, right? In fact, you can get the mode, exact mode. In this case, we'll notice that let me put one more number in just for fun. How about one more 22, just to make that good. And let's go back to stats, stem and leaf. Okay, so you can see that there are 3 22s by looking at this. Do you see that? So you know 22 is a mode. Any questions on the idea of a stem and leaf? I just want to let you know this bottom part, all these words, that is in case you're blind. Okay, you got visual disability, then this way you can actually get an explanation of the stem and leaf. But most of you will just look at the picture. Okay, but I want to let you know that I wanted to make sure that it was accessible. Any questions at all on any of these plots? Hey, I'm not going over every plot there is because that would take forever. There's other plots that I'm assuming you've already seen, like pie charts, because that's stuff you get like all over the place. So I'm assuming that you've seen that. Regular bar charts, you've seen those. But just let you know, and there's a whole lot of others too that you haven't seen that are kind of too messy for that we'll do. We can't do everything in this class. Any questions on this? Okay, let's go back and notice that we have done all these things. And I want to mention one more thing. If you go to the calculator, you'll see I have a z-score calculator. And if you put in x, mu, and sigma, it'll actually do the calculation for you. So if x was 3, mu was 6, and sigma was, say, 4, you calculate, there's your z-score, negative 0.75. So there is a way of finding the z-score by just typing in x, the mean, and the standard deviation. Okay. You use the z-score to see if there's outliers. So you use the highest, the maximum, plug it in. If the maximum is not an outlier, then there's no outliers that are on the high side. If the minimum is not an outlier, then there's no outliers on the low side. And you can do that with z-scores. So you can decide, and if the maximum is an outlier, then you take the second highest, see if that's an outlier. And you keep going until it isn't, and then you know all the high outliers. Do you see how that works? Okay, and you're going to be needing to do that on your project, for example. And the x is the value you're going to put in. On this guy, you'll see for the project, it just gives you the z-score, but you need to type in what you want the z-score of. So if we want to see if this 41-year-old person is an outlier, then we type in 41. And the z-score is about 2.59578. And that is bigger than 2. So it's an outlier. Do you see that? But if you don't put an x value in, then you have no idea what, it's meaningless. So make sure you have an x value to plug in. On the other hand, the low side, that was a 16-year-old. That was the minimum of 16. And if we put the x value of 16, then that is negative 1.9. So the youngest person was not an outlier. Do you see how that works? Okay. And by the way, if you want to find out if there are other outliers, then you get the second highest. That is the 35-year-old right here. And if I put in 35, then that's a 1.7. That's less than 2. It's not an outlier. So do you see how we can use the z-scores to determine what the outliers are? Any questions on that? Okay, so it's time for the secret word. And the secret word is random, random, because I want to remind you, getting a random sample is usually impossible. Okay, but typing in the word random in the secret word quiz is not impossible. Please do it. That is important. So the word random is your secret word for the week one secret word quiz. And write it down. Okay. This will be on YouTube, but you don't have to watch this twice if you're already here. And you've got that. Just a note, next week's webinar will be Monday at 6 p.m. Okay. And we only have, this is the only week we only have two. We have two. So next week we just have Monday at 6. The following week will be Tuesday at 6. Okay. And just a reminder, I think I didn't even mention this one. If you have the sample mean, that's X with a bar on top, and that for typing reasons, for just regular stuff you're doing, I'll accept X BAR. For your projects, since you can get help and stuff, try and make it look pretty. But for any answer for your exams, for example, XBAR is just fine. Okay, does that make sense? Population mean, MU. Sample standard deviation, we use the letter S for that. And the population standard deviation is sigma. And again, if you don't know how to type that in for an exam, you can just type in SIGMA. Figure I should let you know that so you know what to do on exams. And also discussion, if you have a discussion thing you need to talk about, then you can use that if you need. There are ways in Canvas to actually get these things. But X bar is pretty hard. Mu and sigma are not that bad. So that is pretty much everything I need to say. Oh, look at that. It's 7:30 and that's my goal. If I can be around 7:30, that's what I want to end at. So I am going to thank you for coming and I'm going to stop the recording.